In today's video, I'm going to discuss the unit number 9 of our syllabus, that is metals. So metals, they are unique substance. They can conduct electricity in molten form and in solid state. Now let's see the structure of metal to explain the properties of metals. So in metals, we find positive ions. Actually, the metal atoms, they lose their outer electrons and they all produce positive ions. These positive ions, you can see they are placed in layers one above another, while the electrons that they have lost, they are present over here in between the positive ions, and these electrons, they are constantly moving around. So we can label this diagram that we got the positive ions over here, while there is present a sea of, this is actually a sea of mobile electrons. Mobile electrons means the electrons, they are moving around. We use another word to describe them, that is delocalized. Delocalized means that each electron, every electron, it has been attracted by many atoms. And these electrons, they are constantly moving. That means the electron present over here, it can go anywhere in this structure. So this is the reason why metals conduct electricity in the solid state. They have freely moving electrons present in them. Remember, during the conduction of electricity, only the electrons flow. The ions, they remain at their place. Fine. So let's write this, that you can say only ions move and positive ions do not. They stay at their place. Then there is no decomposition. That means when electricity is conducted through metals, nothing happens to them. You have seen the copper wires at your home, they conduct electricity and they remain as it is. Okay, only if some short circuit happen and they may get well melted, but otherwise electricity is conducted and nothing happens to wires. There is no decomposition, no chemical reaction when electricity is being passed through metals. Now, based upon this structure, let's see some properties of metals. So the first property that metals they have, that their melting point. Metals, they have a high melting point, but there are exceptions to this, except for the metals in group number 1 and mercury. Why metals have high melting and boiling point? It is because of the strong electrostatic forces. The electrostatic forces, they are present between the positive ions and the sea of electrons. So there are strong electrostatic forces which keep the metal ions together very strongly. Electrons keep them tightly held, so they have a high melting point. The next property we have already discussed, that metals, they are conductors, and conductors in solid form and in the molten state. Why they conduct electricity in solid and molten state? It's because that they have free mobile electrons. They are present in them, which make them good conductors of electricity. So this is the second property. Next, the next property that we have to see, that metals, they are malleable and ductile. Malleable means that we can make thin sheets of metals, and ductile means we can make thin wires from metals. Metals, why metals are malleable and ductile? It is again because of the strong forces of attraction. Metal ions, they are held together by electrons, and when you apply a force, the layers of atoms, the layers of ions, they just slide over each other. They just change their places, and electrons, they keep them tightly held. In this way, metals change their shape, but they do not break. So here are the metal ions placed one above another in the form of layers. You can see metals, they have a layered structure. And you can see in this structure layers of atoms or ions, they are placed one above another. And what happens that when we apply force from here, these layers, they slide over each other. So here we can see after applying the force, these layers, that they have slided over each other. So second point that we have to write is that layers slide over each other. Due to this reason, metals, they are malleable and ductile. We can convert them into different shapes. So these are some unique properties of metals. There are other properties, like you can say metals, they are shiny. They Metals are shiny. They reflect light. And metals, they are sonorous. Sonorous means that they produce sound when hit. That is also a property of metals. So metals also have high density. Density is high, but not always. There are exceptions. Exceptions, like you got group 1 and group 2 metals. Generally, they don't have very high density. Generally, transition metals, they have very high density. So the typical properties that generally all metals, they have, you can say they are the good conductors of electricity, the property possessed by all metals. Malleable, ductile, they're all metals possess this property. They're shiny, they're sonorous. They are the properties that is possessed by all metals. Okay, melting point, generally they have high melting point, but there are exceptions. Okay, density also have exceptions. Now let's discuss about alloys. Alloys, they are the mixture of metals, or they may contain non-metals as well. So alloys are very common, like uh, the taps in your washroom, they are made with the brass. Brass is an alloy, and it contains two metals. That is the brass. It contains two metals, and that is copper and zinc. It's a mixture of two metals. We have another alloy that is very common in our life, that is stainless steel. So in stainless steel, we have different metals mixed up together. That is iron, nickel, cobalt, and there is present carbon as well. That is a non-metal. So along with metals, there are present non-metals. Along with metals, there are present non-metals as well. Now, why we make alloys? Alloys actually, they are stronger than pure metals. Why they are stronger than pure metals? It is because of the differences in the atomic sizes. In case of like brass, you got copper and zinc. The size of atomic size or atomic radii of copper and zinc, they'll be different. In the normal metal, you see all positive ions, they are the same size, and when you apply force, they slide. But what happens if a different sized atoms, ions, they are present in the structure? So look at this diagram. It's a representation of an alloy. You can see we have ions of different sizes, of different atomic radius, you can say. There are larger ones and the smaller ones. Now, in this case, when you apply force over here, nothing happens. Why? Because there are different sizes of atoms. They are mixed up together, and when you apply force, they do not change their shape as easily as pure metals can. Because pure metals, all atoms are the same size and they easily slide over. But here, the sliding will not be as easy. So let's write this. So here is a reason that ions of different sizes, different radii, they don't allow the layers to slide over each other. So in this way, metals, they are alloys, they are less malleable. They do not change their shape as easily as metals can. So we make like coins, we make jewelry, artificial jewelry is made from brass. We make stainless steel utensils. We use stainless steel in the industries to make the industrial reacting vessels. We make surgical items. So generally tools, they are made from alloys. So till now we have seen metals, we have seen alloys. Alloys, I told you, they are stronger. Metals. Now let's see reactivity of metals. Metals, they are uh, they have a different ability to react. Some metals they are more reactive while some others are less reactive. But the reactivity depends upon what? Reactivity depends upon ability to lose electrons. More reactive metals, whatever more reactive metals you have, they lose electrons more easily. So whichever metal you have, if it is more reactive, that means it has greater ability to lose electrons. For example, in this list you can see the metals like potassium, sodium, calcium. They're very reactive and they react with cold water. If you react them with water, they react with cold water. They're so reactive. Like you put sodium metal in water, so it will react vigorously to produce sodium hydroxide plus hydrogen gas. In this reaction, we see sodium metal floats on the surface and it becomes a molten ball. A lot of heat is released. It's an exothermic process, and size of the ball it decreases, and we see bubbles of gas. We see fizzing. We see the size of metal decreases with the passage of time. Then the metals from magnesium to iron, they do not react with water, rather they react with steam. They are less reactive and they don't form hydroxides. For example, you got zinc reacted with H2O. Remember, H2O over here is liquid, but here we got H2O gas. It's a steam, so we get here zinc oxide plus hydrogen gas is produced. Metals below iron, like lead onwards to platinum, they have no reaction with water or steam, whatever, because they have less reactive, they have less ability to lose electron. And in these reactions, what happens to metals? You see, metals, they lose electrons. Like on the left side here, sodium has no charge, it is 0. But on the right side, sodium is 1 plus. So since it is 1 plus, there is, you can see there is a loss of electron. So it is oxidized. Metals are oxidized after losing electron. Zinc, it is 0 in the reactant side, while here it is 2 plus. So 2 plus means it has lost 2 electrons. So you can say metals, they are oxidized during their reactions. Now let's see their reactions with acid. Sodium, potassium, calcium, they react with dilute acids. And the reaction is vigorous. Any metal like you got sodium react with HCl, it will give you NaCl plus H2. So this reaction is a violent reaction in which hydrogen gas is produced. So the next metals, magnesium to lead, they also react with acids, with dilute acids, but react with decreasing ease. So you can say they react with dilute acid with decreasing ease. As you go down, their ability to react that keep on decreasing. So you have like zinc reacted with sulfuric acid, that gives you zinc sulfate plus H2 gas. while the lower metals, these metals, copper onwards, they have no reaction with dilute acid.